Hello, dear students. Welcome to the channel and welcome to this new playlist in which we are going to discuss about the second module of instrumentation and sensor subject. Module is called sensor installation and operation. So we have completed the first module already. If you want to learn about the first module, we have discussed about different type of instrumentation. We have seen different types of sensors. We have seen various sensors with their range definement and their applications. We have also seen how we can select the sensor based on our requirement, and we have also seen about the installation of a sensor, how we can how we can pick if I want the permanent installation or the temporary installation of particular sensor. And now we are going to discuss about the installation in detail and the operation of particular sensor. Like we can discuss about the things like what would be different outputs for different inputs to a particular sensor, right? So this is something that we learned during the R&D, but this is also very vital in order to use the sensor to its fullest potential, because without that it would not be possible to use that sensor in the with its fullest potential. So if you want to check out the first module, the link will be flashing on the top right hand side corner of your screen for the that whole playlist. So you can click on it and you can check out the first module. And now we are going to start the second module. And one clarification that I wanted to make, that the presentation which I am using for the elaboration of this second module is not my own. It belongs to North Carolina State University. I'm borrowing it from them, borrowing from Department of Civil Construction and Environmental Engineering. So in this chapter, what we are going to discuss, let's say, see, we have total four modules. We have already completed the first one. Second one is on the way. Third one is the data analysis and interpretation, and fourth will be the frequency domain signal processing and analysis. So now let's come to the motivation, which is the preliminary part of this chapter. So we all know that the laboratory measurement of soil properties is non-trivial, right? And it is also often necessary to monitor the response of the natural or pre-construction or natural during the pre-construction and built after the post-construction or post-construction environment to external loadings, right? So it is also often necessary to monitor the response of the natural or built environment to external loadings, right? Because before you complete the construction, you what do you measure? You measure natural response, right? What is the situation of the precipitation in that particular area? What is the condition of soil in that particular area, right? So what is the humidity of that particular area? So you check all these natural things before you construct or build an infrastructure. But after building, what do you see? You see the build response. If whatever the building that I built, if it provides proper response or not, right? And that requires understanding of sensors, transducer, subsurface measurements, in situ characterization, remote sensing, data collection. It requires all of these things. And we have discussed about the basics of sensors and transducers in the first chapter itself. And about data collection and remote sensing, we are going to discuss in the upcoming chapters as well. But this particular chapter or this particular module provides a description of the process of selection of the sensor, setting of the sensor, installation of that sensor, and the monitoring of that sensor, right? So we are going to discuss about the selection, setting, installation, and monitorization of the sensors. And they have also provided a case study which we would discuss if time permits. What are the learning objectives of this particular chapter? So at the end of the module, what you would be able to do, so you would be able to predict the response of the sensors to various inputs which I've discussed earlier, right? Based on different inputs, you would be able to predict the response of that sensor, how the sensor would respond to this input and how would the sensor would respond to that input. For an example, uh, let's take a voltmeter. So how would the voltmeter respond to 0.000007 volt or 0.000007 microvolts, and how would it respond to 2000 volts, right? It would be different, the response of that sensor would be different based on whatever the during what is the range of that particular voltmeter or any sensor. Then we are going to we will be able to construct a conceptual instrumentation and monitoring program. We will be able to describe the order and the methodology for the sensor installation. We have discussed about the permanent and temporary installation in the previous class, but this time at the end of this module we will be able to describe the order and the methodology for the sensor installation, right? In what order sensor should be installed and what is the exact methodology, what are the steps to install that particular sensor. And we would be able to differentiate between types of sensor and their modes of operation and measurement, right? So different type of sensors use different modes of operations for obtaining particular output. And in addition to that, knowledge of this particular module will also prepare you for the third module, in which we are going to discuss more technical stuff. So something that would include the data analysis. So we are going to discuss that as well. Now, moving forward, let me give you an overview of this particular chapter. So first, we are going to see the approach to planning monitoring programs. So in the approach to planning and monitoring programs, what we are going to see, what we are going to see how do the sensors define the target, right? Like say if I'm having a tachometer and I want to measure the speed of a particular machine, okay, so how would I understand that that machine is the target machine and I want to measure the speed of that particular machine, right? Your tachometer requires to define a certain target on that machine, and then it would only be able to recognize that particular machine, and after that it will be capable enough to measure the speed of that machine, right? Then the selection of that sensor, right? Because uh, you cannot use the same tachometer for the measurement of speed of everything. So the meters we use for the measurement of speed, let's say if I'm using some particular meter or sensor for the measurement of speed of speed of some induction motor or some BLDC motor. So will I use the same instrument or same sensor in order to measure the speed of particular vehicle? So we cannot do that. We cannot use the same instrument for the measurement of totally different applications. Then we are going to discuss about sensor setting as well. It is a big topic in itself. How do you mount the sensor in particular target in order to obtain 100% result or best result possible from that sensor? We are also going to discuss about the installation of a sensor and how do you configure it in detail. Then we have the advanced topic, which is design of particular sensor and measurement uncertainty, which would discuss about different type of errors and how you can rectify them. Now, what is the basic question here? Basic question is, how do you select a sensor, right? So in sensor selection, you basically it totally depends on the three questions and how do you answer it. First question would be, what quantities need to be measured or monitored, right? Very basic question, because you cannot use the tachometer for the measurement of amperes. Very basic. So first you have to identify what quantity you need to measure. For example, let's say I want to measure the pressure. Okay, so what instrument I will be using? If I want to measure the pressure, I cannot use the voltmeter, right? I have to go for strain gauges. So it is very important to pick the correct sensor or correct instrument for the measurement of a particular quantity, and without that it would not be possible to measure it, right? Even the application is very important when for what application you want to measure. Just the example of speed fits totally in this scenario as well. So you cannot use the same tachometer that you use to measure the speed of an induction motor or a wind turbine of a power plant to, or wind turbine or any other, like for the turbines of a high, you cannot measure the same tachometer or speedometer to measure the speed of wind turbine and for the turbine which is used for the hydropower plant, right? And you cannot use that same for the measurement of speed of vehicles going on the road as well. So for that purpose, different speedometers or different tachometers would be used based on whatever range they are being active in. Second question that you need to ask is, what level of accuracy and precision are required, right? Sometimes you seek the high precision and higher level accuracy, which is very much visible and important for some cases, right? For an example, uh, let's say let's take the example of the fuel tank of your two wheeler. So how much accuracy and precision do you require in the fuel tank of your vehicle? You don't require too high accuracy or too high precision, do you? If it tells you that the fuel is close to empty, then it would be okay, you can refill it. But how much precision would it be required in uh, in measurement of the compounds that involves radioactive decay, or uh, how much accuracy or precision do we require to uh, count to observe a neutron star and count its count its atomic clock based on atomic clock, right? Count its period, how much time it requires to complete complete one cycle period. So that would be very should be very accurate, and for that what do you use? You don't use regular clock, you use atomic clocks. So it depends on what level of accuracy and precisions are required, and based on that you would pick the correct instrument and the methodology of measurement, right? Like for the tracking of time you would simply be using a regular clock or a regular watch. But if you want to measure uh, the example which I just gave you, that the cycle of a neutron star or a supernova, then what you would be doing, you would need the atomic clock. So that was the second question. You have what level of accuracy or precision are required, and the same example can be fit in the speedometer or tachometer case as well, right? For the measurement of speed in the Kaplan turbine, the accuracy and precision required would be too high, right? Because you are measuring RPM, and the requirement of measurement, the requirement of accuracy would be high. But in the same case, the measurement of speed of the car, or the measurement of uh, the ball being bowled by a fast bowler, how much precision and accuracy do you require? So do we use the same tachometer or the speedometer that we use for the measurement of RPM of Kaplan turbine, and the measurement of ball bowled by a fast bowler? We don't use the same, right? In cricket, in bowling, the speed goes around the maximum speed that uh, goes would be around 150 160 max to max. But the speed of Kaplan turbine, it would come in RPM. So different devices, it is like horses for courses. And after that, measurement and monitoring requirement, the third question, are measurements and monitoring requirements short or long term, right? So the monitoring requirements are short term or long term, depends on whatever sensor you are using, involves heavy infrastructure, light infrastructure. Does the measurement takes long time, short time, that, right? So measurements and monitoring requirements are short term or long term, that is the question. And based on that, like if you need to monitor it in every second, then you would require a different sensor. But if you need to monitor in particular time, then you would require different sensor. Another example, again taking speed here, in BLDC, when we use the Hall effect sensor, you need to measure the speed at every rotation of your motor, right? The Hall effect sensor would use the every rotation for that motor, and the motor speed would be around uh, like 1500 rpm, 2000 rpm, which means it rotates 2000 times in a minute. So at that time the measurement is very quick. But take the case of a car going in on a road, and there would be like 5 to 6 cars going passing through the road in a minute. So you would be only required to measure the speed of the car 5 times. And even slower than that, the speed guns which we use for the measurement of the speed of the cricket ball bowled by a fast bowler or a spinner, that would only require to measure the speed of a ball in e- either once or twice in a minute, right? Once, twice, or thrice in a minute maximum. So it depends on what measurement and monitoring requirements. Either they are short term or long term. And short term and long term, by saying short term and long term, it means uh, if you want to do the if monitoring required for the short term, you need to check your sensors in very short time, or you just have to mount it and then you don't have to check it for the long time. So these things are the questions which you need to answer before selecting the sensors, and once you answer these three questions, the selection of the sensor will automatically be done. Then we talk about the sensor setting, and for the setting of the sensor or mounting of a sensor, first question, again we will be asking three questions. First question would be, what are the best locations for measuring the required data, right? What are the best locations for the measuring of required data? Like if I want to measure the voltage of a particular battery, what would be the best location for the measurement of voltage? You you connect your battery to battery terminals with your uh, with your voltmeter voltmeter, right? So the best location would be the terminals. Same ways, if you are measuring the speed of a motor, let's say a hall effect sensor, then what would be the perfect place to put that hall effect sensor? Right, close to rotor, right? You cannot place it outside the motor and then expect it to measure the speed, can you? No, you cannot do that. So it is important to identify the best location for the measurement device for perfect or good measurement of required data. But that being said, you also have to be aware about the uh, replacement of that sensor. What if that sensor requires replacement? What if the sensor fails and it requires replacement? You should be capable enough to take out that sensor without affecting or damaging different other parts who are working properly, right? And where can sensors feasibly be placed, right? It should be feasible. It shouldn't be like that the perfect location is close to the rotor, so you just mount it next to rotor. No, it should be feasible, and it should not exceed the exceed the cost that you have planned for the whole instrument, right? Sometimes what happens, you've decided that your instrument, the price of the instrument is this much, then the price of the sensor is this much, but the installation and the setting of the sensor requires more than the cumulative sum of both of them, so that is not feasible. So you have to identify the correct physical position where the placement of the sensor becomes feasible. And then the final question that you need to ask, that will installation interface with the quantities being measured or not? So with installations interfere with the quantities being measured or not, or Heisenberg's question. About that we will be discussing in detail when we discuss in detail about the sensor setting. But for now, understand that these three questions require to be answers for before deciding this perfect sensor setting. Then we come to the basic question of sensor installation, that Which installation method will result in the highest quality of the data? First question. Again, you need to answer the four questions to find out the best installation way for that particular sensor. So the first would be the which installation method will result in the highest quality data, right? Then you have to ask what is the least obstructive method for installation. So first, uh, which installation method will result in the highest quality data. For example, I want to measure the current flowing from a particular cable, or flowing from particular conductor. Then how will I measure it? What installation method of current sensor or ampere meter will give me the best quality data, right? So you have to identify whether you need to collect whether you need to connect the ampere meter in parallel or in series in order to obtain the highest quality data. That's the first question. Then second one, what is the least obstructive method for installation, right? The installation should not be obstructive. The installation should not be disturbing. It should not disturb other parts which are placed already in a better manner. So you have to identify what is the least obstructive method for installation. Then you have to answer the most important question, that what is the most economical method for the installation. The cost should not exceed the budget that has been passed to the install for the installation purpose of particular sensor, right? Just like I said earlier as well. So you have to identify what is the most economical method for the installation, and then you have to answer, are measurements and monitoring requirements are short term or long term. Same question that we asked previous for the previous case for the sensor sitting as well, that are the measurement and monitoring requirements are short term or long term. And that also uh, depends on your sensor, that we have already discussed in the previous class when we discussed about permanent and temporary installation of sensors, right? Then comes the monitoring part of that sensor, that if how do you monitor that sensor. So you have to answer just two questions: is a wireless or a hardwire connection, what connection would be appropriate, wireless or hardwired connection for the monitoring purpose of the sensor. And second question would be, how will data will be stored and archived, right? For the monitoring purpose, you need to identify how the data will be stored and where the data will be stored as well. And is the wireless or hardwired connection is more appropriate. You have to identify the appropriate connection for that sensor. Sometimes the wireless connection is more favorable in order to avoid a lot of trouble, but sometimes hardwire connection is more important, more better option, because in hardwired connection you get continuous output or continuous collection of the data. So depend based on what is your requirement, you have to decide whether you need wireless or hardwired connection. Then we are going to discuss about the planning of monitoring programs. So how do you plan the monitoring program? So first you define the project's conditions. What are the conditions of the project? Then you predict the mechanisms that control or describe the behavior. And after that, you define the engineering questions that need to be answered, right? What are the questions which you need to answer from the engineer's perspective in order to monitor that program? And then you collect all these inputs and determine the purpose of the instrument, right? First you will define the project condition. After defining the condition of that project, what you would do, you would predict the mechanism that controls or describes the behavior. Then you would define the questions that require to be answered from engineer's perspective, and then you collect all the answers, and then you would take these answers in the form of the inputs in order to determine the purpose of your instrument. What purpose does your instrument serves? And based on that, the planning of a monitoring program takes place. Next point to discuss is sensor selection, and I think we shall discuss from this slide in upcoming class, because we have already covered pretty much and it's time. So let's discuss the selection of the sensor in upcoming class. If you have any doubts or queries related to this today's class, please mention them in the comment section below. If you have any feedback or any suggestions for me, you can mention them in the comment section below as well. And I will be seeing you next time with the continuation of this module. Until then, thank you very much for listening, and goodbye for now.